Hey Finxters, in today's interview question, we will be discussing the gas station problem. Now, with the help of an example, let us understand what this question asks us to do. Now, this is the problem formulation. There are n gas stations in a circular route where the amount of gas at the ith station is given by gas at the index I. You have a car with an unlimited gas tank and it cost at the ith station of gas to travel from the ith station to the next station, which is I plus 1. You begin the journey with an empty tank at one of the gas stations. Now please note, this is the gas station that we have to find. That is the gas station where we can begin the journey. So the question further says, given two integer arrays of gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. Also, it states that if there exists a solution, it is guaranteed to be unique. Now that was all theory. Let us go ahead and try to understand this with the help of an example. So let's say that this is the given example. And as you can see, there are 5 gas stations such that they have the index 0, 1, 2, 3, and 4. Now the cost given at each station are 3, 4, 5, 1, and 2. And the gas at each station is 1, 2, 3, 4, and 5 respectively. Now you have to find the gas station or the index of the gas station such that when you start your journey from that given station, you can complete the entire circular route and come back to that station. So let's say that in this example, we are starting at the 4th station, which has the index 3. Now the cost of traveling to the next station is 1. So when you travel to the next station, the total fuel available to you is 4 minus 1 plus 5. So that is 8. Now you move on from the 5th station to the first gas station. So that means you have to move from the 4th index to the index 0. When you do so, the amount of gas consumed is 2. Hence, when you reach the first gas station, the amount of fuel available to you is 8 minus 2 plus 1, because 1 is the amount of fuel which you are refilling at the first station. So that is 7. Now you move on from the first station to the second station. And what will be the amount of fuel that will be consumed? Yes, it is going to be 3. So at present, you have 7 units of fuel available. Then you subtract 3 from it, which is 4. And then at the second station, you add 2 more units of fuel. So now the unit of fuel available to you is 6. It's now time to move from the second station to the third station. And the amount of fuel that will be consumed is 4. So when you reach the third gas station, the amount of fuel available to you is 6 minus 4 plus 3. Here 4 is the amount of fuel that will be consumed to move on to the next station, while 3 is the amount of fuel that you can refill in your gas tank once you reach the next station. And finally, you have to move on to the station where you started. In this case, we started at the 4th gas station. So we have to move from the 3rd gas station to the 4th gas station. When we are at the 3rd gas station, the amount of fuel available to us is 5, and the amount of gas that will be required to move on to the 4th gas station is 5. So we have just enough fuel to travel back to the 4th gas station. This means 5 minus 5, and finally that becomes 0 when we reach the station where we started. Hence, if we start at the 4th gas station in this example, which is at the index 3, then we can successfully complete the entire circular route and once again reach back to the station where we started. Now, if you have a look, if you start at any other station, let's say if you start at the first gas station, then the amount of fuel to reach to the second station is 3. But the gas available to you is only 1. So when you subtract 3 from 1, it becomes negative. And that is not possible. This means you do not have enough fuel to travel to the next station. Hence, in this case, the feasible start station is the station 4, which is at the index 3. So your output should be 3 in this case. Now that we understood what the question asks us to do, let us go ahead and try to understand how we can solve this question. Now, if you have a close look at this question, then you'll find that when total gas available is greater than total cost of travel at a given station, then the trip is not possible in any way. So that means when the gas at a given station I, where I is the index, is greater than or equal to the cost at that given station, only then can you go ahead and consider it as a starting point. So this also implies that the difference between the gas available at a particular station and the cost at that station should be either greater than or equal to zero. So if we have a look at this example itself, then you'll find that when we started at the fourth station, which was at index 3, then the gas available was 4 and the cost was 1. So 4 minus 1 is 3. Hence, we could start at this station. However, if you have a look at the first station, then the gas available was 1 and the cost was 3. So 1 minus 3 was minus 2, and that's why we could not start at this station. So I hope this equation is clear. Now let's go ahead and let's visualize this. So this was the example that was given to us, such that their index were 0, 1, 2, 3 and 4. And these were the costs associated to each station. Now let's take into consideration each index or each station and let's find out if we can consider that station as a starting point. To do that, we will find the difference between the gas available and the cost at a given index. So when the index is 0, that is for the first station, then the difference between the gas and the cost is negative. That is 1 minus 3 is minus 2, hence it is negative. Now let's check for the second station. So that would be 2 minus 4, which is minus 2, which is once again negative. Now let's move on to the third station, which is at the index 2. And when you subtract the cost from the gas available at the third station, it will be minus 2, which is negative once again. Hence, we can disregard the third station as well. Now let's move on to the fourth station. And in the fourth station, we find that gas available is 4, while the cost is 1. So in this case, when we subtract 1 from 4, the output is 3. Hence, we can now consider this station, that is at the index 3, as a probable starting point. Now, before proceeding further, there's one more thing that you have to understand. Let's say that we have a starting point, but after reaching a certain index, the overall value of the difference between the gas and the cost is negative. In this case, the next starting point will only be at the index after the index where the value of the difference between gas and cost is negative. So let's have a look at that in an example. Now, if you have a look at this example, then at the first index, the difference between the gas and the cost is 1. Now, when you move on to the next station, which is at the index 2, and then you compute the overall difference between gas and cost, it is still positive, which is 1. And why so? That is because when you move from the first to the second index, in that case, we simply go ahead and add the total fuel available, which is 1 plus 3 in this case. And then when we decide to move on to the third station, we simply go ahead and subtract 3, which is the cost at the second index. So that is 1. Now when we move on to the third station, and then when we compute the overall value of the difference between the gas and cost, it becomes a negative integer. And why so? This is because you simply go ahead and add 1 to 4, which is 5, and then you subtract 6 from it in order to move on to the next station. But 5 minus 6 is minus 1. This means the overall value of the subtraction of gas and cost at the third index is now negative. So this means that we cannot consider the first index as the starting gas station. And this is majorly because the value of gas and cost at any given station should always be greater than or equal to 0. So this is our primary condition. Now, in this case, the next starting point will only be at the index after the index where the value of the difference is negative. That is, even though we started at 1 and at the second station the value of the difference between gas and cost was positive, still we cannot consider the second station as a starting point. Rather, we can simply start to compute our starting point from the next index, which is 4. To understand this, let's say that we started at station 2, which is at the first index, and upon reaching station 4, which is at the third index, the total value of the difference of gas and cost is negative. Now, if you have a look, then you'll find that when you started at the second station, the total gas available at the third station was gas at the third station, which is 3, plus the leftover gas from the previous station, which is 1. So 3 plus 1 was 4. So let's have a look at the following example or the following equation, which will make things clear to you. Hence, this means that even if you start at the third station, which is at index 2, then the value of the difference between gas and cost, that is the total value, will still be negative. Hence, there is no point of considering the third station. Rather, you can simply move on to the next station, which is at index 4. So to further understand this, let's say you started at the second station. In that case, the difference between gas and cost would be 3 minus 3, which would be 0. So when you moved on to the third station, it would be 0 plus 4 minus 6, which would be minus 2, and that is a negative value again. That means you cannot start at the second station as well. Hence, we can simply go ahead and eliminate station 2 and station 3 as a starting point for our consideration, and then we can check for station 4 as a starting point. So I hope this point was clear. Now let's move on to the next phase of this solution. So here we have the given values of index, gas and cost for each station, and then we have two more variables which are fuel and total. Here, fuel denotes the difference between gas and cost at a particular station, while total denotes the total fuel available at a particular station to move on to the next station. Now, as we previously discussed, to start the trip, we have to select the best possible index. We know that if the car can always go to the next index, then the car will complete the trip. This means we have to check if the fuel of the tank allows the car to go to the next index or not. Hence, we can safely conclude that if the value stored within the variable total is always greater than or equal to 0, then in that case, we should be able to complete the entire circular route. So let's take the help of this table wherein we have the values of the index, gas and cost, and at each index we will compute the value of fuel and then we will also compute the value of total. Now please note that we cannot start at index 0 because the difference between gas and cost is negative. Similarly, we cannot start at index 1 and 2 as well, because in these cases, the difference between gas and cost are once again 0. We start from index 0 and then we keep moving on to the next index until we find the index wherein the difference between gas and cost is positive. However, before proceeding to next iteration, we keep account of the fuel available at a particular index, and then we also keep the count of total fuel available in our tank so that we can complete the route. Now let's try and understand this with this table. So let's say in our first iteration, when we are at index 0, we go ahead and compute the value of fuel. And in this case, the value of fuel is 1 minus 3, which is equal to minus 2. So what will be the value stored within the variable total? At this point of time, total will be equal to fuel. So total now stores minus 2. Then we move on to the next iteration, that is at the first index. Here, the value of fuel will be gas minus cost, that is 2 minus 4. And that is equal to minus 2. But now in this case, total will store the leftover fuel from the previous iteration, which was minus 2. And then we again go on and add the fuel that was available at this first index. So what is that fuel at the first index? It is minus 2. So minus 2 and minus 2 become minus 4. Then we move on to the second index, and here the value of fuel is 3 minus 5, which is minus 2 once again. And the value of total will be minus 4, which is the leftover from the previous iteration, plus the value of fuel available in this iteration, which is minus 2. And this becomes minus 6. Then we move on to the third index. And in this case, the value of fuel is going to be 4 minus 1. And this is going to be 3. Now we can say that yes, since the value of fuel is positive, then we can consider this as a starting point. So when we consider this as a starting point, we also have to calculate the value of total, which is now going to be minus 6 plus 3. And this is going to be minus 3. Then we move on to the next index, which is 4. And the value of fuel in this case is going to be 5 minus 2, which is 3. So what will be the value of total? It is going to be minus 3 plus 3, which is 0. With this, we come to the end of our iteration. Now here we can safely say that the value of total at the end of our iteration is greater than or equal to 0. In this case, it is equal to 0. So this means we have successfully found our starting point, which in this case was 3, wherein the value of fuel was a positive value. Now, if this total value would have been less than 0, in that case, we could have successfully concluded that there is no such station wherein we can start our journey. Now, please note that you have to store this value, which is 3, that marks the index where we are starting our journey in a variable. And we will have a look at that in our program. But as of now, let's try and understand the logic behind this. So as you can see, we computed the value of fuel for every station or for every index. So when we started at index 0 and then we moved on until index 3, the value between these indexes were negative. While when we moved on from the third index to the fourth index, the value was positive. So let's say that this area is represented by X, while this area is represented by Y. And then we concluded that if X plus Y was greater than or equal to 0, then we found our start station. Otherwise, if X plus Y was less than 0, then we would conclude that there is no such station which will help us to complete the entire circular route. To further understand this, we need to have a look at the code. So let's dive into the code and let's find out how this works. So gas underscore station is the name of the function that will help us to reach the final output, and it accepts the attributes gas and cost. Now let's begin our computation. To begin with, we have 3 variables which are begin, total and fuel. So you already know the purpose of total and fuel, and we initialize them to 0. But what is begin? Begin will help us to store the station, which we will return as a final output as the starting station. Now our next task is to iterate over each index, that is over each station. So we simply go ahead and use a for loop such that we iterate within the range of 0 until the length of the array gas. You can also use the length of the array cost because both of them will have the same length. So that means if there are 5 given stations, then their indexes will be 0, 1, 2, 3 and 4. And that is what this loop will help us to iterate over. Now to explain you, I have used a few print statements in this code. Don't worry, we will go ahead and remove these print statements before reaching the final output. But just for the sake of understanding, I have used these print statements. Now within each iteration, I am printing the station index. So initially the value of I will be 0, then it will be 1 and so on. Now we simply go ahead and calculate the value of fuel. Now please note that fuel here plays a very important role, and you'll understand this once we move inside this if statement. So as of now, let's consider that fuel stores the difference of gas and cost at a particular index. But this is not actually what fuel is storing. Fuel is actually storing the difference of gas and cost at a particular index plus the previous value or the previous unit of fuel from the previous iteration. Now you will understand why we are doing so once we move ahead. Then I have used another print statement in order to print the cost, gas and fuel at the current index, and then we move inside an if block. Now within this if statement, we are checking if the value of fuel is less than 0. So that means when the value of fuel is less than 0, we cannot consider that index as the start point. Hence within the if block, I have printed cannot start here. Then we go ahead and store the index of the next station within our variable begin. After that, we simply go ahead and calculate the value of total. So total is equal to the fuel available at that index plus the surplus fuel that was left over from the previous iteration. Once we have computed the value of total, we go ahead and update the value of fuel as 0. Now the example that we took into consideration was this, wherein the given values of gas and cost were as shown on the screen. And we found that we could start our journey at the third index wherein the gas available was 4. So this means when we move on to the third index, then we no longer move inside the if block. And this is where the variable fuel comes into play. Though I have used another else statement here, but this is only to help you understand how things are working, which we will have a look at in a few moments. But you do not need this else statement. Rather, this variable fuel will help you to compute the next part of our algorithm. So if you recall the explanation from the diagrammatic representation previously, let me take you there. So we calculated two values. One was X and the other part was Y. Now fuel right here will help us to calculate the value of Y, while X will be calculated within this if block. So as long as the value of fuel is less than 0, that is the difference between cost and gas is less than 0, we have to keep updating the value of our variable fuel to 0 at the end of each iteration. However, as soon as we find that the value of the difference between gas and cost is positive, then we simply go ahead and add the value of difference between gas and cost to the surplus from the previous iteration to the variable fuel itself. So that means when we are at the third index, then we no longer move inside the if block, and this is where fuel stores 4 minus 1, that is 4 was the unit of gas, while 1 was the unit of cost. And then we move on to the next iteration wherein the value of gas was 5 and cost was 2. So in this case, it will be 4 minus 1, which is the surplus from the previous iteration, plus the difference of gas and cost at this index, which is going to be 5 minus 2, that is 3 once again. Hence, this will be 6. Thus, this 6 represents X, while the value computed within our if statement within the variable total will represent the value of the portion Y, which was minus 6 in our example. After we have come to the end of our iteration, we simply go ahead and compute the value of X plus Y, which in this case is 6 minus 6, which is 0. Since we have an output which is either greater than or equal to 0, and in this case it is equal to 0, so we can say that yes, we do have a station from where we can start our journey and complete the entire circular path. And the variable begin stores that start station. So we simply go ahead and return begin. And if this value was less than 0, then we would have returned minus 1 as an output. So to further understand this, let's go ahead and execute this code. And there we go. So let's have a look at how this actually works based on this example. So initially, when the index was 0, the cost given to us was 3 and the gas available was 1. So the value of fuel was gas minus cost, which was minus 2. Hence, we concluded that we cannot start at this station. We also went on to calculate the value of total, which was 0 minus 2 in this case, that is total plus fuel, and the value of fuel was minus 2. So it was minus 2. Then we moved on to the next iteration, wherein the index was 1. The cost given was 4. The value of available gas was 2. So the value of fuel at this point was 2 minus 4, which was minus 2. So once again, we concluded that we cannot start at this station. And then we went on to calculate the value of total, which was the value stored in the variable total previously, plus the current value stored within the variable fuel. So that was minus 2 plus minus 2, which is minus 4. Then we moved on to the next iteration, that is index 2, and the value of cost at that station was 5, while the value of gas was 3. So 3 minus 5 was minus 2, which is once again negative, and we concluded that we cannot start at this station. And then we again went on to calculate the value of total, that was minus 4 plus minus 2, that is minus 6. And then we moved on to the next iteration, wherein the index was 3. At this point, the value of cost given to us was 1, the value of gas was 4, and then when we calculated the value of fuel, it was 4 minus 1, which is 3. Now that the value of fuel was no longer less than 0, hence we concluded that yes, we can now proceed with this station. Actually, we didn't calculate the value of total any longer. I should not have included this print statement. Let's execute this once again. So when we were at the index 3, we safely concluded that we can proceed further as the value of fuel in this case was positive. Then we moved on to the next iteration, that is at the index 4, and at this point of time, the value of cost given to us was 2 and the value of gas was 5. So we calculated the value of fuel, but in this case, we went on to add the surplus value of fuel from the previous iteration and added it to the value of fuel in the current iteration, which was 5 minus 2, that is 3. So it was 3 from the previous iteration plus 3 from this iteration, which added up to be 6. With this, we came to the end of our iteration such that the value stored within the variable fuel was 6 and the value stored within the variable total was minus 6. So we simply went on and added the final value stored within the variable total and the final value stored within the variable fuel, and we checked if that value was less than 0. Since it was not less than 0, it was equal to 0 in this case. So we simply went on to return the value of begin. And what did the variable begin store? It stored the value 3, that is the index 3. So we should also go ahead and print the variable begin so that we understand things better. Okay, there we go. We are now also printing the value stored within the variable begin. Let's execute this code once again. So as you can see, begin initially stored 1, then it stored 2, then it went on to store the variable 3. As soon as begin stored the variable 3, we no longer moved inside the if block. So there was no case of updating the variable 3 and begin was storing this index. So finally, while returning the output, we returned the value stored within the variable begin, which stored the station wherein we can start our journey and complete the entire circular route. So that's how this code works, and the time complexity of this code is n, since we are only iterating over each station once. Hence, we undergo n iterations, which means that this code has approximately a time complexity of n, that is linear time complexity. With that, we come to the end of this interview question. Please join me in the next lecture wherein we will be discussing another interview question.